Hello friends, today I will discuss about magnetization current test for three-phase power transformer. This test is done at factory end and also inside during commissioning of the transformer. This is done mainly to detect health of the core, number 2 health of the winding, that is primary winding as well as secondary winding, number 3 health of the on-load tap changer winding. Excitation test principle. Excitation test principle for a single phase power transformer has been shown in this diagram. Here single phase supply is given to the primary side of the winding and secondary side winding of the remain open. Now due to supply given in the primary side, a current will be flow in the primary side. Due to this current, a flux will be flow as a direction as shown in this diagram. Due to flow of the flux in the core, induced voltage will be induced in the secondary winding. Since this current in the primary winding is only to establish a flux to magnetize the core, this current is called the magnetization current or excitation current. Now whenever we connect a load to the secondary winding, a current will be flow in the load side, that is load is referred as R2, and now current will be flow as I2 in the secondary winding. Due to flow of the current in the secondary winding, a flux will be flow in the core as shown in the diagram opposite to the flux that was established by the primary winding current. This flux is phi 2. Due to this flux flow in the opposite direction in the core, the primary winding will be draw more current from the supply to nullify this flux. Now that is why now excitation current is I magnetizing current plus I2 to establish a flux phi magnetizing plus phi 2 in the core. Now whenever load is connected, there will be more current will be draw in the primary side. Now in no load only there is magnetization current. Therefore when no load transformer in no load, we supply a single phase supply to the primary winding or either side of the winding. It will help to detect interturn fault in the secondary side winding or in the primary side winding. Now here the circuit diagram has been shown for the finding interturn fault for the during magnetization current test. Now single phase supply E1 voltage has been applied in the primary side winding. Due to this, only I magnetizing current should flow in the primary side winding. Therefore only 5 magnetizing flux should flow in the core. But since the secondary winding has interturn short, a current will be flow in between the interturn, and that is why a phi fault will flow in the opposite direction of the flux that was flow due to the current in the primary winding. Therefore the primary winding will draw more current from the supply, and that is I magnetizing plus I fault. Now we can by this we can understand the interturn fault in the secondary winding. Beside finding the interturn fault, it also helps to finding the grounded fault in either side of the winding. Here the secondary side of the winding is grounded, and due to this a current will flow from the secondary side winding to the grounded path as shown in this diagram. Due to flow of the current to the grounded path, that is I fault, a flux will flow in the core, and it will oppose the magnetizing flux phi max. Due to this, the primary winding will draw more current to nullify the effect of the flux phi fault. Therefore, during this test, the excitation current will be much more than the normal condition. Similarly, it will help to detect any fault in the load tap changer winding in similar way. Magnetization current test for 3-phase power transformer. First, we have to ensure that transformer is under complete shutdown and dropper to the HV and LV bushing are disconnected. Number 2, the earth plate connected in the neutral bushing shall be disconnected from the neutral bushing. Number 3, that is 3-phase single 3-phase supply should be connected to the HV side, keeping the LV side open, and measure each phase current in the HV side by clamp-on meter. The above method also done for LV side by keeping the HV side open and measuring the current in each phase by clamp-on meter. 3-phase supply should be given through fuse or MCB, just because if a transformer is found to be defective, it will draw more magnetizing current, and therefore it can harm to the winding of the transformer. Here the diagram has been shown for a magnetization current test for YND11 and 50 MVA 132 by 33 kV power transformer. Here secondary is delta connected and primary is Y connected. Here the delta side is kept open, and in the primary side, that is in the star connected side, a 3-phase supply 415 volt has been given through MCB of 6 ampere rating. The current and the voltage has been measured. Current has been measured by clamp-on meter and recorded, and also the voltage between phase has been measured through by multimeter and recorded. The recorded voltage and current has been shown in the table in the right side of the diagram. Here VRY, that is voltage between red and yellow phase, is 430 volt, and current drawn in the red phase is 1.9 milliampere. Here voltage between Y and B phase is 430 volt, and current drawn from yellow phase is 1.25 milliampere. Voltage between blue and red phase is 429 volt, and current drawn from the blue phase is 1.89 milliampere. Here you can see the current in Y phase and B phase is almost same, but Y phase is lower compared to red and yellow phase. Now we will explain the reason for this variation of the current. Here the primary side winding has been shown in this diagram. Here core is transformer is core type transformer. Red phase winding is connected in one limb, Y phase is connected in the middle limb, and B phase in the right side of the limb. Now flux phi is equal to Ni into R. Here R is the reluctance of the core, and phi is the flux established in the core, and N is the number of winding in the primary side, and I is the current drawn from the supply. Now number of winding is same for all 3 phase, but in case of reluctance path for red phase and blue phase it will be same, but in case of yellow phase it is not same, it is rather different from red phase and B phase. That is why the current drawn from the supply is different in case of Y phase with respect to red phase and V phase. Now flux is equal to Ni by R, where R is the reluctance of the core. Now if the R varies, the flux will be varies, Therefore, to maintain a steady flux in the core, the current is varies for red, yellow and blue phase. For red and blue phase, since the reluctance is same for red and blue phase, the current is almost same. But in case of white phase, since the reluctance is different, and the flux varies. To maintain a steady flux, that case that is for red and blue phase, it will draw a less current from the supply. Now a diagram has been shown for the reluctance for each section of the core as R, as shown in this diagram. For calculating the reluctance for each limb shown by the each phase has been shown in this diagram. For red phase, the reluctance will be shown by equivalent reluctance, that is by A to A dash. For yellow phase, the equivalent reluctance will be in between B to B dash, and for blue phase it is between C to C dash. By considering R is equal to 1, we can calculate the equivalent reluctance for red and yellow phase, that is A to A dash is identical to C to C dash, that is reluctance between red phase and blue phase is almost identical. That comes as 3 plus 3 by 4, that is equal to 3.75 Henry. The unit of the reluctance is Henry. Now for equivalent reluctance for Y phase winding, that is equal to equivalent reluctance between B to B dash, that comes as 3 in parallel with 3 plus 1, that comes to equal to 2.5 Henry. Now flux is equal to Ni by R. Now flux is same for all the phases. Now for Y phase, current will require Y phase will be more 2.25 by 3.37 times that of R and Y phase. Here an R red and blue phase magnetizing current is almost equal to 1.9 milliampere. For blue phase it is 1.89 milliampere. Considering same for red and blue phase, the Y phase magnetizing current will be 1.9 into 2.5 by 3.75, comes as 1.2 milliampere. But actually major current is in the Y phase magnetizing current is Iy equal to 1.25. That is the theory for magnetizing current for 3-phase power transformer. If you like my videos, then please do subscribe my channel and also press the bell button for notification of videos to be uploaded in future, and do comment for your feedback. Thank you very much.